it's gonna keep making out.
Okay, so how'd that? We did cosine yesterday, right?
Yeah.
Okay.
We should like not do math today.
Oh no, we got it. It's here.
Oh, okay.
We got it. It's just here.
I mean, it's Valentine's Day though.
Yeah, no.
I'm just trying to.
You can smell your flowers and eat your chocolate at your own
Yes,
desk.
right? These sounds good. Tired? I understand. No enemy club today.
Okay. What kind of questions did you come across on the homework work?
18 and 19.
Whoa, dude! All right, we're already jumping there.
What problem?
Okay, yeah, let's hit them. All right. Oh, and this will upset most of you. So the quiz I had for this Thursday, a week from today, we're moving to a week to tomorrow.
Woo!
I know. I didn't think too many people would be like, dude, that's man, I hate you. So
Wait, Friday?
Yeah.
a week from
Oh,
tomorrow.
I thought you said Wednesday.
Yours will be tomorrow.
Sounds good.
All the rest of it.
Yeah.
I'm just Josh and Sam. All right. Let's see. Number 8. Ooh, a Ferris wheel. Okay. Let's talk about this whole Ferris wheel thing. I think we can saw through it. It says a Ferris wheel with a radius of 25 feet is rotating at a rate of 3 revolutions per minute. Okay. Sounds good. When t equals 0, chair starts at the lowest point on the wheel, which is 5 feet above the ground. To model the height, h in feet, of the chair of the function in time in seconds, complete the following steps. So let's find the midline. Okay, so things we know. We have a radius of 25 feet. Is that what it was? It said radius? Yep. So y'all understand this whole Ferris wheel. It's doing this. We have this radius of 25 feet. Good so far? Other things we know. In order for this to go around, it will go around 3 times per minute. Okay? And then the lowest point right here is still 5 feet above the ground. Okay? I don't know if that's important for us or not. So find the midline or the oh, okay. Okay, so let's find the midline. So I guess we do need that 5 feet off the ground. So this distance here is still 25. So what would this whole distance here be? 30? Okay. So we have a vertical shift where this whole thing is 30 feet up. Okay, so we'll deal with that in a little bit. Consider how far the middle of the first wheel is from the ground. Okay, we got that. Find the amplitude of the function. Consider how far the maximum height of the Ferris wheel is from the midline. Oh, okay. So our amplitude has to be the radius, 25 feet. And then how long does it take the Ferris wheel to make 1 revolution? Okay, so we're going to go 2 pi over b is what we're using. Okay, we'll equal our period. All right, so let's think about this. This Ferris wheel goes around 3 times per minute. So every 20 seconds it's making a rotation. That makes sense?
Yeah.
Because there's 60 seconds in a minute divided by 3. Okay, so that would be my b value. So 2 pi over 20. So I guess that'd be pi over 10 is where it would start and stop again. And then write a negative cosine equation that models this equation. So they want us to write this. Bx plus, we'll call that d over there. Okay, I don't think we have any shift because our Ferris wheel didn't shift left or right, so we're not worrying about moving back and forth. So let's see. I'm going to do y equals, I think, negative 25 cosine of theta pi over 10 plus my midline of 30. There we go. That works for me right there. So theta, again, remember we use theta because that's like the angles of the degrees. So like, we use theta. You're like, sounds good, Ruben. Still talking about my friend Eric Rubin, whose bike got stolen.
Nice. Isn't that a sandwich name, Ruben?
Oh, that's a good sandwich. Yeah, Reuben sandwich. Oh, dude, you get the right kind of deli. I ain't talking Subway, Jimmy John's. I'm talking go to that real deli.
Like a New York deli?
Oh yeah, baby.
They have really good Jewish food. Jewish food is the best.
Yes.
Right?
When we get your sandwich and the meat section is this thick on it, you're like,
Yeah.
maybe I should just get on top of my plate with it.
It's so good.
All right. Number 19 says a second Ferris wheel with radius 20 is rotating at a rate of 4 revolutions per minute. T equals 0. Cheers. Blah blah blah. It's the same idea. Let's not worry about it. And yeah, what?
I spilled my water bottle.
Okay, it'll dry. Any other questions off just the graphing of them or anything like that? We good? Going once? 17? Saved.
Just kind of clumsy.
It happens.
There's a hole in the top.
Okay.
Why is there a hole in the top? No, it's just a hole in the top. That's how they made it.
So let's just draw our traditional cosine, see what happens off of this. So I got pi over 2,
It's just to open it.
0,
It's just
3 pi over 2. I don't know why I just did that. Skipping things. Listen to Sam's conversation. Sam, it's your fault.
Yep.
Sorry. Okay. Everything there I like. So I'm going to make this, I'll do the regular cosine in yellow. Okay, so that's what the regular cosine looks like. So let's figure out a few things. What is that going to do? Yeah, so this will be here, this will still be here, this will now be here as a max, this will still be here, and that'll be down there like that. So I'm going to go ahead and draw that now. And then I'm going to show on my axes the shifting. Okay? So let's do nice purple. Okay, so if this was at 0, because that's a -1, this is now happening at -1. So this means this has to be -2. And what does this one become? That becomes 0. So we took care of the shifting here. Is that okay so far? Mm-hmm. So this is going to happen twice as often. Okay? So between 0 and 2 pi, we're going to have 2 of the green things happen. So what would I have to do if this is happening twice as often? Meaning that this should do this.
Shrink it?
Okay? So it is kind of a shrink. It's a horizontal shrink, isn't it? So our iterations are going to take place. So if it's going to happen twice as often, that's still 0. That's going to be pi over 4, pi over 2, 3 pi over 4, and just pi. So the green one's our answer, and we have it labeled correctly now. Yay. Anything else? Yep. 16? All right, number 16. All right, so same idea. That's a little crooked, isn't it? Sorry about that. So we get 0, pi halves, pi, 3 pi over 2, and 2 pi. So I heard, I was watching Miss Yeoman-Smith. She was teaching, she's a couple days behind us, but she was starting to record her lessons, asked me for my help, and I was just listening to her lesson she was doing. And she gave a really pretty good answer of why we are doing radian measures on the x-axis rather than degree measures. So I'm stealing this from her, but I'm giving Miss Schumann-Smith the credit for this. She said the logical way of why we are using radians is if we use degrees, dude, are you done?
Sorry.
You would go from 0 to 360 degrees. So 0 to 360 is an awful lot of tick marks. Radians, 2 pi is the same thing as 360, so it counts up slower. I thought, hey, that's kind of cool. All right, so let's make my cosine, my normal parent function cosine is this. Nope, yeah. Nope, why did I just do sine? I'm sorry. Here, 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 here. So that's my regular cosine. So things that are going to take place. Let's flip it because of that negative. Okay. That half in front of the x means it's now going to take twice as long to get a whole iteration. So that means now I need to double all of my values. So double that, well, that's still 0. Double that, that's now going to be pi. Double that, that's a 2 pi. Double that, that's at 3 pi. Double that, so meaning multiply times 2, that's going to be at 4 pi. The green's not correct. And it's upside down because of that. Cool. Make sure your name's on those. Fold over the corners, pass them on in. Please.
Hey, who wants a capital pen?
What?
I want. Oh, that's his, my bad.
What?
I thought someone just threw it on the
Dude, Sam's handing out other people's stuff, I'll tell you.
Throw it on the floor.
Copy of matches.
Redistributing the
What
wealth.
other do?
That's a hard word to say. Distribute. Redistribute. I'm just bad at English.
Bro,
Yeah,
English
right,
isn't my
that's-
first language. And I'm so bad.
You're better than me, man. English is my first language. I'm like kind of shit.
I'm not skimming, but I feel bad.
I mean,
Yeah.
I get the basics of the language. It's all good.
Okay.
I imagine it's bad.
You ever understand?
Yeah, Spanish 2 is too hard.
You understand that?
Get it? 2? Bad fun. This dad's done my crap.
Just how
All right, see you. Very happy to see you. Always happy to see you. Thanks. And you are my sunshine, and you are my only sunshine. All right, and come by to get homework. Is this homework?
Thanks. Thanks.
If you think about it, are all cows holy? Just think about it. They have
Yeah, after you shove a bolt through their skull to kill them, yeah, they're holy.
no, because they already have a natural hole. I was making a joke about them having assholes.
All right. All right. So let's talk about tangent. Let's talk about tangent. So tangent is the one. Sine and cosine have these nice curves. And now tangent is going to kind of goof things up. Okay, so it's not going to do things up to something that you can't handle. I just want us to realize this, that we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Those are still all the same. But what was tangent? It was what over what? Okay, so tangent is y over x. Okay, so what values do we need on the x-axis? We need those. And then what about on the y-axis? So the y-axis is negative to positive infinity, whereas sine and cosine had gone from positive 1 to negative 1, right? And then the values on the x-axis, we're still going to use our 0 and our pi over 2 and our pi, etc. Okay? But there's one thing I want us to start realizing. So if I use this point, that's y over x, which is 0 over 1, which is 0. But if I use this point, I have this. So it's undefined. Because I divided by 0. What did I do?
Oh, you didn't do anything.
Oh, okay.
Oh, no, etc.
It's very possible I did something wrong.
No, this is not you.
I've done all kinds of wrong things. All right.
Haven't we all?
Yeah, but you're younger than me, so you still have more years to catch up to my years. All right.
Stuart, you like fun dips? Fun.
Yeah, I eat I open the pack and just do that with the powder, and then I eat the stick later.
It's kind of like crack, but for children.
Thank you. You have my permission to keep him on a leash non-stop, okay? So 1, 0, 0, 1, negative 1, 0. Okay, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we're still doing this normal. And then here's our big difference. 0, undefined, 0, undefined, 0. Yes! What's happening? Who do you sing to today?
Angela?
Angela?
Nice.
Yay! Do you need her stand up or anything?
Which one?
Stand up.
Do we know their last name?
It just says Angela. It's from Ari, if that helps.
Oh.
Yeah!
Get up there, baby.
And you guys are being recorded because I'm recording
You're
my
about to
mic.
get drowned in love and affection. I'm about to drown in it, bro.
Wise men say only fools rush in, but I can't help falling in love with you. Shall I say, would it be a sin if I can't help falling in love with you?
That was very good. You sound amazing.
Yeah.
Okay,
No, that's pretty cute.
No, take that.
All right.
Really?
So
He probably does give or take.
let's take a look here. We have 0. I'm going to call this pi over 2. I'm going to call this pi. I'm going to call this 3 pi over 2 and 2 pi.
I was nervous.
All right. But notice I have it going this way as well. So I'm going to go negative pi over 2. This just means I'm going now clockwise around the circle. Negative pi, negative 3 pi over 2, and negative 2 pi. Does everyone feel comfortable with that?
Oh.
They just came to sing to you guys.
I got we just saw.
I just want to say how great of a teacher you are. And how you got
Oh, you're my sunshine too! God!
What?
Thanks, my dude.
I am so happy that your parents dropped that off to you. That's your story, and that's what you're sticking with.
Got it.
My mom really came all the way from downtown to give it to me.
Alright, so first thing I want to label is I want to label my zeros. Okay? I want to label the zeros. Okay. Ready? Let's label the zeros first. 0, 0. Still with me?
Yeah.
My next zero is over here at pi. Is that okay?
Yeah.
My next zero is over here at 2 pi. Is that okay?
Yep.
Label this way. I got a 0 there at negative pi, and a 0 there also at. So that's where it's going to cross the x-axis. But how do I label? What the heck is an asymptote, and how do I label it? Well, it doesn't exist there. So we create a dotted line, a dotted vertical line to indicate it. So at pi over 2, because we divided by 0, that's undefined. So our graph is not going to cross that. And at 3 pi over 2, our graph isn't going to cross there either. And then as it comes this way, it won't cross over here, and it won't cross over here. So notice we are incorporating from negative 2 pi to positive 2 pi so we can see what this thing is doing. All right. So I always try to remember this one. I'm just going to put a 1 right there for a moment. Still with me? What is the tangent of pi over 4? That's tangent of 45 degrees, which is root 2 over 2 over root 2 over 2. So what's root 2 over 2 over root 2 over 2? 1. So the tangent at pi fourths, which is here, is 1. And I always kind of put that because that way I remember which way the graph goes, because I can't remember it. So this is what my tangent function looks like. And then it does it here. And then it does it here. And then it's like, well, how do you draw this over here? Well, that's doing that. And then that's doing that. Huh? Yeah, an asymptote is a definite restriction. It can't equal that because it's dividing by 0.
No.
Yo, that's trippy.
Okay? That's your tangent. That's your base tangent function. Kind of looks goofy, doesn't it?
It's crazy.
Yeah.
If you graph this on your calculator doesn't know how to pick up its pencil unless you make it not connected. And it kind of looks like a heartbeat EKG. Like, boop, boop. So.
Don't you only worry about the middle one though?
What?
Don't you only worry
Yeah,
about the
but I was just trying to show, because this took place, so I was showing, hey, if I go clockwise around my circle to negative 2 pi, or I go.
That kind of looks like x to the third.
It does, but now it's repeating over and over and over. So good classification. Can I move on?
Yeah.
So now we're going to look at this and we're like, okay, well, what is my midline? Now, these, it's kind of hard to see the midline moving around too much. So you have to kind of identify usually where it's crossing the y-axis. So this appears to have a midline of negative 1. And then if I look at this, golly. So I get that region. So how far is this distance from here to here? Be smart about it.
1 pi.
1 what? Pi?
Maybe.
So, and then out here, that goes to pi, and that's to negative pi. So how far is that distance? 2 pi. I think our period is still going to be 2 pi. Okay? Though this might have shifted a little bit. So let's go back to our graph real quick. Did it cross at the origin on this one? And if it did that, does it cross at the origin there other than shifting down 1?
Yeah.
And does that graph look similar to this graph where it's as you're above the x-axis, it's increasing?
Yeah.
Okay? Does this one do the same thing as I'm above the x-axis is increasing? So I think my equation just has to be this. Y equals, it didn't flip around, so it's just still going to be tangent of theta minus 1. And we're done.
Whoa.
Okay?
Theta is just that short.
I can use X if you wanted to. But a lot of times you use theta because it says we're using angles. Lots of talking. Shh, let's move on. Shame, shame. All right. So item 2. Does this graph look a little bit different than this graph?
It's negative.
It's negative. So, and then what does my midline appear to be on this one?
2.
Positive 2. And, oh, okay, so it's crossing there still. And so if I go from here, pi over 2, to here, that's only a distance of pi. Is that right? Let's go back to my original. I know it's flip-flop. So we have that as well. So between here and here, we have a distance of pi. So that works. So I'm kind of checking that. So my period is still going to be at 2 pi. It's going to be taking place. Okay? And now my equation. Let's think about this. I'm going to have y equals something tangent theta plus 2. All right, now, does this graph go the opposite direction that this graph did?
Yeah.
Okay, so can I take this? So this point here, I'm going to move up here, and this point here, I'm going to move down here. So would it flip over my midline? Does that appear? Yeah, so it's got to be the negative right here.
Oh, then is the other negative like on its side then? Like you have a negative outside? I mean inside? Like go.
If this right here was negative, this was, if I go back to the original,
The original.
I went the wrong way. If I had a negative x here, this would come over here, and this would come over here, which the hard thing in seeing this is if I had a negative out front, this comes down here, this comes up here, it looks the same. So it's hard to decipher if you have a negative tan x or a tan negative x if it flips over. All right, midline, 0. It still looks like our period is 2 pi. And our equation, oh, it's not doing anything special, is it? Oh, wait, it's doing one thing special I wanted to see. Remember I said on an original at pi fourths, we're at 1? Where is that at now? 2. So I'm going to get y equals 2 tangent theta. That 2 means I'm stretching it in the vertical direction. You see how I did that? And you can't see that unless you understand on my very first graph that I said, hey, this 45 degrees, which is pi over 4, is at 1. So we have this point does exist, pi fourths comma 1. That does exist on it. So if you don't understand that, then this one's going to be hard to see. Okay, but that's where you get the 2 on this one. Yeah.
Do we need to graph like so on the number line, you know, like how it would be like pi and over 4 in between at that point? Would we need to put that on our number line? Like, do we need to graph that, or is it fine?
I want to see at least one iteration
Okay.
on tangent. Same like sine, here's your one iteration. And cosine, here's your one iteration. I want to see one iteration. That's all. All right. Midline. Go ahead.
0. 1. 2.
1?
Yes.
Agree? No? Or is it 0?
No, it's 0.
0? Oh, you did. Ooh, hey. What did this one do?
It moved it.
Did it shift left or right?
Left. So it's
Okay.
a plus half pi over 4.
Move left how much?
It's
What's this point right here?
Negative pi over 4.
Negative pi over 4. Good. Okay, so this is going to be theta plus pi over 4. Okay. What is our period of time that this is taking place? You know, I guess we could look at it as, because it's shifted a little bit, it's going from negative pi, if I use this one, to pi over 4. Think that'd be about right? Yeah.
Why is the midline 0?
Because it shows symmetry about the point pi fourths.
So even with the shift to the left, it's still 0.
Mm-hmm.
Okay.
And they were just showing that this is still going to be 1 because that's a distance of pi fourths and that's 1. That's why we're.
Wait, so why do you have a point on this one?
They were just showing them both.
Oh, okay.
Showing you multiple points that exist, I think. All right. Midline 0.
Yeah.
This one, so this is going to be pi over 8. And this is going to be negative pi over 8.
Oh, so it's a stretch.
And we had something that took place. It could be a stretch. And it could have shortened our period. What shortens the period? Thank you. All right. Is it a normal stretch?
Okay,
I mean, this right here is actually at pi over 16. That's pi 16ths, comma 1. So it's stretching. And it's happening less often. So let's do this. Our normal iteration between this is our normal period on tangent if we just go about the origin.
So it's a stretch by.
So, how do I want to go about this one? Okay, some in the parentheses. It's going to happen. Ew. I'm not going to like this one much, but I'm still going to put it. It's going to be happening at let me see if I can make that right in my head. This happens twice as often between its normal parameters. Yeah, it's set. I don't like that one much. I don't think I'll test you on it. All right. So midline 2. We'll do from negative pi halves to pi. Will give us our iteration around the origin. So I got negative pi halves, pi. Midline, we're going to call this one right here. We're going to call this 2. We'll call that point 3.
Yeah. What? Casual.
There you go. Yay.
Why on tan do you have to do like positive? Oh, because it's going both directions, whereas the other ones.
I mean, like I could show starting here and going this and then showing this. Like,
yeah,
that's taking place over here. I'm just trying to show one continuous.
Okay, that makes sense. So
That's
on
all.
the test, we would grab that, not the other thing. Cool.
All right. Am I done? Nope. Hey, negative 2tan. Woohoo! So that's going to be pi over 2. That's going to be negative pi over 2. And this is actually going to do negative pi over 4, 2, negative 2. Okay, so this is going to be stretched by 2 and flipped over. So my original goes that way. This one is going to come this way. So asymptote here, asymptote here. Something like that. So it flipped it over and it stretched it by 2. Yay! Dude, that's it?
Yeah.
Oh, best day ever. All right.
That was a good
Valentine's story. Valentine's story. Mr. with eyes.
Yeah, tell us
I-
a Valentine's
It's on your board again.
Right. Like this, like
Do we even have a Valentine's?
Can we hear a story though?
when I just saw that, I was like, oh my god, I am so in.
Story.